Hi everyone, so in this video we're going to be looking again at the periodic table, but we're going to be focusing on metals, nonmetals, and metalloids. So we're going to just go ahead right now and check out a periodic table. So again, this is our periodic table. I just want to highlight this key right here. So remember, this is our element symbol, so it's that 1 or 2 letter symbol to represent what the element is. The number on top of the element symbol is our atomic number, and that tells us how many protons we have. And the number below is the atomic mass, and that tells us how the average number of protons and neutrons that we have in the element. Now, the first thing that we're going to look at is our metals. So the metals is the majority of the elements that we have on the periodic table, and they're found to the left of the staircase. So you're probably wondering, what is the staircase? The staircase is starting this black line going all the way down. And the staircase really separates the periodic table into our 2 major groups. First of our group being the metals. So our metals are everything that is highlighted in blue. So all of these, all of these. Now our metals stop with aluminum. And they're over here. The next group is our nonmetals. Now our nonmetals are actually a much smaller group than our metals. So they are these, and these. So just looking at it visually, we can see we have much more metals than nonmetals. Now there's 2 things that I want to highlight. Hydrogen. Hydrogen is a nonmetal, but it's only put in the first group and the first period in the metal section because of the fact that it has 1 valence electron and 1 electron shell. It is not a metal at all, and on most periodic tables you actually see a space between hydrogen and lithium. Now there's about 7 elements that I did not in at all, and these are our metalloids. So you can see they're on our mystical staircase. So our metalloids actually separate the metals from the nonmetals. So now what we're going to do is we're going to look at some of the characteristics of our metals, our nonmetals, and our metalloids. So the first thing about our metals is that they're found on the left of our staircase. The second thing about our metals is that they form positive ions. So what this means is that when they're trying to get a full last shell, so their full octet shell, they're going to actually be losing that valence electron or electrons that they have, giving them an overall positive charge. So if we look at, for instance, lithium. So lithium has 3 protons. It has, on that first shell, 2 electrons. And on that second shell, 1 electron. Now, what's going to happen with lithium is that, again, when it's forming a molecule, it's actually going to lose its valence electron. So it's going to lose this one right here. So if it loses its valence electron, it's going to look something like this. We can see now it only has 2 electrons and 1 proton, meaning that lithium is going to have an overall +1 charge. All metals are going to either form a +1 charge, a +2 charge, or a +3 charge, depending on whether it is in group 1, group 2, or group 3. Last few things about metals is that they are going to be reacting with acids to produce hydrogen gas. That's actually one of the ways that you can test if you have an acid, is if you put a couple of drops on a metal, and if it's bubbles, those bubbles is indication of a production of a gas, and in this case it's going to be hydrogen gas. It conducts electricity and heat. We can know that just for the fact that whenever you're cooking, all of your stovetops, the pots are normally made out of metal. Everyone who uses electronic devices, well, inside you have is metal, which is allowing for the electrons to travel. And as such, metals are malleable and ductile. Ductile, again, meaning it can be stretched out into a wire. Malleable means it can be flattened without being broken. And last thing is that metals are all found at solids at room temperature, except for mercury. Mercury is actually in a liquid form at room temperature. Now, the first thing about nonmetals I want to highlight is the non part of the word. So non meaning the negative, so that means a nonmetal, it has the complete opposite characteristics of metals. As we remember from our periodic table, they're found on the right of our staircase. Second thing is that they form negative ions. So same thing, concept when they're trying to get a full last shell, they're going to be gaining electrons instead of losing electrons, and that's going to give them an overall negative charge. So for example, let's look at fluorine. So fluorine has 9 protons. On the first shell, it has 2 electrons. Oh, hold on, that was my nucleus. There we go. On the first shell, it has 2 electrons. And on the second shell, it's going to have 7 electrons. So as it wants to get a full last shell, it wants to get a full octet, it's going to gain 1 electron. So as a result, it would have a -1 charge. So negative ions can form a possibility of a -1 charge, a -2 charge, or a -3 charge, depending if it's in group 7. So everything in group 7 is going to have a -1 charge. Everything in group 6 is going to have a -2 charge. Everything in group 5 is going to have a -3 charge. Last few things about nonmetals: they don't conduct electricity and heat. They are not malleable nor ductile, and this is the main difference, is that they're found as a solid, a liquid, and a gas at room temperature. So a great example we can look at is actually our halogens. So if we're just looking at our first couple of halogens, we have fluorine and chlorine, which are gases at room temperature. We have bromine, which is a liquid at room temperature, and we have iodine, which is a solid at room temperature. And these are all elements in group 7, which is our halogens. So our last group is our metalloids, which are found on the staircase, and because they're found on the staircase, we actually have very few metalloids. The elements that are considered metalloids are boron, silicon, germanium, arsenic, antimony, and beryllium. Now, the ions formed depend on the metalloid. So if we're looking at boron right here, so boron is actually in group 3. So when it's forming an ion, it's actually going to form +3 charge. Silicon and germanium, these two are actually in group 4. Now, all elements in group 4 are special because they can either form a negative ion or a positive ion depending on the scenario. So silicon can either be +4 or silicon could be -4. And then the rest of the elements that we have, since they're in groups 5 and 6, they're going to be actually having a -3 charge and a -2 charge respectively. And because metalloids separate the metals and the nonmetals, they're actually going to have characteristics that are a mixture of metals and nonmetals. And the thing that's really, really important is that they're element dependent. So this means that different metalloids are going to have different set of metal characteristics and non-metal characteristics. I hope this helped, and have a great day.